In the last section, we started talking about a tiny little problem that you might be presented with if you were some analyst at a city working on a flooding problem. So we've now identified the data that is relevant to our problem, and we've assembled that into a data set. We now need to decide on the type of output that we are predicting. Now this step, as we walk through it, is going to seem a little bit confusing or a little bit esoteric. I'll tell you right now that based on this type of output that we are trying to predict, we're going to choose a different algorithm to somehow relate our data together. So the purpose of this deciding on the type of output that we are predicting, its purpose is to somehow narrow down the algorithm that we'll use to process all of our data. Let's take a look at two common types of output that we might try to predict. All right, here we go. These are two common types of output that we might try to predict. The first is classification, second is regression. There are other types of outputs or other types of algorithms out there as well, but for the most part in this course in particular, we're going to be focusing on classification and regression. The purpose of a classification process or algorithm is to somehow take all of our input data, like the amount of rainfall for each year, and then predict some value of a label that belongs to a discrete set. Now that doesn't make a lot of sense when I say it out in plain English, so we'll take a look at an example of this in just a second. But before we do, the other type that we're going to be considering is regression. With regression, we are trying to predict values for our labels or our outputs that belong to a continuous set. Now again, that doesn't make sense either, so let's take a look at a couple of examples of both these. Okay, so first off, regression. On this diagram, I've labeled or kind of laid out three different problems or questions we might try to answer that belong to a type of regression family. So if I were to ask you, based on the year, make, and model of a car, what is its value? Well, you'd probably answer that question with a dollar value, like it's worth $0 or $10,000, $20,000, $30,000. Those are all numbers, denominations that belong to a continuous set of values. So anywhere from 0 to 50,000, or maybe it's a really expensive car and it's worth 100,000. That is a continuous set of values. My car could belong to any value from 0 to $50,000. Let's take a look at another one. So maybe based on an individual's daily calorie intake and the minutes that they spend exercising, what is their weight? Well, again, the output from this question right here, or what their weight is going to belong to a continuous set of values. So maybe their weight is either between 80 or at a minimum 80 pounds, all the way up to, say, 400 pounds. A person could weigh any amount of weight between those two values. Now, as one last example, let's say that based on the height of a pine tree, which is just a type of tree, what is its age? So how long has this tree been growing? Again, maybe that would belong to a continuous set of values, so anywhere from 0 to 500 years, and any value in between. So these are all examples of outputs or predictions that are continuous in nature. We can get a prediction or an output that belongs to any value in between these two bounds. Now let's also take a look at some examples using the other type, classification. So with a classification type algorithm or a classification technique, we are trying to predict values that belong to a very small set or a very small pool. So examples of classification techniques would be, say, based on the number of hours that a student studied for an exam, did they pass or fail? In this context, a student can either pass or fail. That's it, no other options, just those two selections. And so that's what I mean by discrete here. We get two options, you either passed or you failed. There is no like score or percentage of questions that this student got right. It is solely pass or fail. Another example would be, say, based on the content of an email, is the email a spam email or not spam? So two options there. It's either spam or not spam. That's it. And then finally, based on where a football player shoots from, are they likely to score a goal or not score a goal? In football, soccer, if you're from the US like myself, you either score a goal or you don't. So either I score the goal or I kicked it out of bounds, or maybe the keeper grabbed the ball and blocked the shot. So these are all examples of classification type predictions. We are trying to take some input and then predict an output that belongs to a discrete set of values. Now, with these two techniques in mind, classification and regression, if we think back to our original problem, where we need to decide the type of output we are predicting, you and I definitely know that we are predicting dollar values right here. So there is not like a output of we had to pay money or we didn't pay money. It's not we had to pay over $1 million or under $1 million. It is solely how much money did we spend. So this is definitely a regression type problem because we are trying to predict continuous values right here. All right, so that's a lot of talking for that one step. Let's move on to the next one. So now, based on that type of output, which we said is regression in our case, we need to pick an algorithm that will determine a correlation or some relationship between all of our features, which you'll recall is the amount of data that has fallen in this year, and our label, which is the amount of flood damage that we found. So we might go ahead and pick some arbitrary random algorithm to try to solve this problem. Now, we're not going to dive too much onto the algorithm side of things on this flow for right now, because as you might guess, that's the kind of the entire point of this course is to walk through a bunch of different algorithms. But we can essentially understand that once we pick an algorithm, we're going to feed our data that we have collected into it, and hopefully our algorithm will decide or discover some type of relationship between our different features and our single label. So after that, we would then use our model, or whatever the output from this algorithm is, to make a prediction, which in our case is to predict how much flood damage there will be if we have 240 millimeters of rainfall. So let's kind of imagine that we walk through this step together. So we're going to say that maybe we take this data set and we pass it into some algorithm called a linear regression algorithm, which is an actual algorithm that we're going to learn a lot about later on inside this course. Once we feed in our data set and run this algorithm, the algorithm says, okay, I have found a relationship between the amount of annual rainfall and the amount of dollars that we have to spend to repair all the flood damage. And that relationship is the annual rainfall in millimeters times 0.033 minus 5.1792. That's our relationship between annual rainfall and flood damage. So now recalling that the original problem statement was that we need to figure out how much flood damage there will be if there is 240 millimeters of rainfall, we would take that 240 millimeters, plug it into this relationship right here, and if we do the math, we get 0.033 times 240 minus 5.1792, and I would estimate that we would have about $2.74 million of damage. So $2.74 million in damage for that amount of rain. So I would go back over to my city manager and say, okay, I did the analysis based upon these previous years of data that we have, where we have some amount of rain and some amount of money spent to fix that damage. I think that if we have 240 millimeters of rain, we're going to have to spend about $2.74 million to fix it. Okay, so that's it. That is a walkthrough on a very simple, very straightforward machine learning problem. Now, I want to very quickly give a couple of takeaways here, or just some important things I want you to understand at this point. Okay, so a couple of things from each step right here. The very first thing we did was identify our independent variables. So the things that kind of relate together to make some information available about our problem. We had called features, or we used the word features to refer to categories of data points that affect the value of our output. And we called that output a label. And the next thing we did was we assembled a data set. Again, a big thing that I'm going to harp on throughout this course is that a lot of times the data we want to make use of is not always going to be nicely packaged for us. So sometimes we might have to do a lot of formatting or essentially put this data together by hand to be able to have some data set to work with. The next thing we did was decide on the type of output that we were trying to predict, or the type of algorithm that we would probably want to use. We had said that regression is used anytime that we are trying to predict continuous values, and we use classification anytime that we are trying to predict discrete values, or values that belong to a small pool of possible values. Next, we picked an algorithm that would determine a correlation between our features and our labels. Again, that is something we're going to learn a lot about, all these different algorithms throughout this course, so we're going to go a little bit light on detail on that step for now. And then finally, once we used our model or used that algorithm, we produced a model that could then be used to make a prediction about some future value. And our models that we generate using these algorithms are going to try to relate the value of a feature or a set of features to the value of our output or our label. All right, so that's pretty much it. Let's take a quick pause right here. When we come back to the next section, we're going to start working on our first little application.